Okay, so now let's start talking about hyperlinks. So we're going to start talking about PageRanks. So, so what is PageRank? The basic idea behind PageRank, it has nothing to do with content of the pages, but it's a way to analyze the link structure, the links between the pages on the web, to figure out which pages are more important or more authoritative in a way. So the PageRank algorithm basically looks at a link. If there is a link going from page A to page B, you want to interpret that as a vote. So system A, in a way, is voting for system B. It's giving it one hyperlink, so that's one vote for system B. So if you have a hyperlink, it means that page A thinks that page B is worth seeing, right? There's something good on page B, so it's offering you to go there. And then if you have many pages linking to page B, then page B must really be good because lots of other pages are voting for it. So it's an interesting measure of quality. It's a measure of quality that has nothing to do with the content. It's just the link structure, right? It doesn't look at all into what is on the page. It's just looking into the number of links coming into the page. So how could you use it? Well, you wouldn't use it by itself, but you could combine it with other ranking algorithms. So you would take something like the TF-IDF score that we had for the vector space model and combine it with PageRank. And in a couple of lectures, we'll talk about a principled way of combining them based on the data that you have. But one thing that you want to pay attention to is so it's the web, and not all links are of equal importance. So, for example, if some obscure blog is pointing to you, that's worth something, but that's not worth nearly as much as when, say, Slashdot points to you or CNN points to you. So the idea of PageRank is to really count how many good pages link to your page. And what are good pages? Good pages are pages where lots of good pages point to them. So it's a bit of a recursive definition, right? To be good, you have to have lots of good pages point to you, and then your links are considered to be very, very good links. So that's a hand-wavy explanation. Now, the way to introduce the algorithm itself, the best way that I know to think of this is to think of this sort of a graph-hopping random surfer model. So your web is, it's a graph. You have a set of nodes corresponding to the various pages. The hyperlinks are the edges, and they're directed. And the analogy that you use is you start on a random page, and then you do the following. So say I start on page G, I'm going to randomly pick an outgoing link. So I have two outgoing links here. One goes to B, one goes to E, and I'm going to hop there, right? So I'm going to maybe go from B to E, right? And then you repeat, and then you keep repeating that. So from E, I'm going to pick another link, so I might jump to F. From F, I could go to E or to B, so maybe I'll go to B. And then from B, there's really only one place to go, so I can go to C. So here's an example trajectory that you could follow. And then the other component of the algorithm is at each point, when I'm deciding where to hop, before I hop, I flip a coin, and if the coin comes up heads, I pick one of the links and hop along that link. But if the coin comes up tails, I hop to a random page in the graph. Now, why do I need to do that? Why do I need to hop to a random page? Yeah. So otherwise, strange things will happen. So for example, if at any point I end up in B, and then I hop to C, and then from C I can only go to B, and from B I can only go to C, so I'm going to get stuck in there forever, right? And you don't want that. You want a visiting strategy that hits every node with a certain probability, right? So that's really the idea. And the way you model that is you say, you flip a lambda coin, and if the coin comes up tails, you're going to take a random hop to any node in the graph. So maybe from B, I'm going to hop to A, and then from A, I'm going to randomly hop to I. So what is PageRank? PageRank, if you take this analogy, is the proportion of time. So imagine doing this infinitely long, doing this forever. So PageRank becomes the amount of time or the relative proportion of time that I'm going to spend at a given node. Right? So PageRank for node E would be what proportion of time do I end up in node E during this traversal of the graph. So if you want to look at it more formally, the PageRank, if you arrange all the PageRank for all the nodes in a vector, that vector is actually an eigenvector of the adjacency matrix. Right? It's not particularly important for the course, but if you're curious, then that's what it is. It's for the adjacency matrix, which is normalized by the number of outgoing links. Right? So SL is either 0 if y doesn't point to x, or if y does point to x, it's 1 over the number of outgoing links in y. All right, we're out of time, so I'm going to start going through the algorithm on the next lecture.